Hello, welcome back. And here we are taking another look at difference quotients. Here's our next example. So let's look at f of x plus h minus f of x all over h. So again, we'll write the denominator 1 over h out front. And so we'll have the root of x plus h minus the root of x. Okay, now how can we do this one? Well, this one's kind of nice if you look at these sort of square roots. You're like, okay, it'd be really nice if we could square these away and make things a little bit easier on ourselves. Okay, so we can do something like that. And what we're going to do is we imagine we have something that looks like a minus b. We're going to transform it to a squared minus b squared. So we're like, hey, if I can multiply that by a plus b, get my difference of perfect squares, we're good to go. So what we're going to do is multiply top and bottom by that a plus b. So the root of x plus h plus the root of x all over the root of x plus h plus the root of x. All right, let's see what happens. So in the numerator, we'll get our a squared minus b squared, right? So we have x plus h minus x all over in the denominator of h times of that root of x plus h minus root of x. Now, these x's reduce out nicely, and we'll see the common factor of h in the top and bottom just to show you what it looks like. So the top really just have an h all over, copy paste that bottom, h times the root of x plus h plus the root of x. And now these h's can reduce, and we're actually just left with 1 over the root of x plus h plus the root of x. Now the alternative way to do this, so using the ax and the a, would be f of x minus f of a all over x minus a. Okay, so this would simply just look like root x minus root a all over x minus a. And again, we have a minus b. You want to get a squared minus b squared, so multiply top and bottom by the conjugate. So you have root x plus root a over itself. So really we're just multiplying by 1. So we're just changing how things look. And the top will have an x minus a. In the denominator, we also have an x minus a now, plus that root of, or times that root of x plus root of a factor that we threw in. And then these factors reduce out nicely. Now remember the top, there's a 1 left over, we'll have root x plus root a. Now let's get ready for the next example.